Hi, welcome everyone. In this session, we will discuss on operating system operations. To understand how a modern operating system functions, we must first recognize its event-driven nature. Essentially, an operating system is interrupt-driven. If there are no programs to execute, no I/O devices to service, and no users to respond to, the OS will sit quietly and wait. These events are signaled by either an interrupt or a trap. Interrupts are hardware-generated signals, such as a keyboard press. In contrast, traps, or exceptions, are software-generated interrupts caused by an error like division by zero, or a specific request from a user program for an OS service. A core goal of the operating system is efficiency, which brings us to the concept of multiprogramming. In the early days, a single user couldn't keep the CPU or I/O devices busy all the time because the CPU is significantly faster than I/O devices. Multiprogramming solves this by keeping several jobs in memory simultaneously. Since main memory cannot hold everything, jobs are kept in a job pool on the disk. The OS picks one job to execute. When that job needs to wait for an I/O operation, instead of letting the CPU sit idle, the OS switches to another job. This ensures the CPU is utilized as much as possible. While multiprogramming focuses on CPU utilization, multitasking, also known as time sharing, focuses on the user experience. Multitasking is a logical extension of multiprogramming where the CPU switches between jobs so frequently that users can interact with each program while it is running. The response time is typically less than 1 second, creating the illusion that all programs are running at once. To manage this, the OS uses CPU scheduling to decide which job gets the CPU next. With multiple programs sharing resources like memory and the CPU, the system must ensure security and reliability. This is handled through dual-mode operation. The hardware provides a mode bit to distinguish between user mode, represented by bit 1, and kernel mode, represented by bit 0. When the computer boots, it starts in kernel mode. When a user application is loaded, it switches to user mode. Anytime a trap or interrupt occurs, the hardware switches back to kernel mode. This leads to the concept of privileged instructions. These are specific instructions, such as handling I/O or clearing memory, that can only be executed in kernel mode. If a user program attempts to execute a privileged instruction, the hardware treats it as illegal and traps to the OS. To perform these restricted tasks, a user program must use a system call. This process triggers a trap, switches the mode bit to kernel mode, allows the OS to perform the service, and then switches back to user mode before returning control to the program. Finally, we must protect the system from programs that might get stuck in an infinite loop and hog the CPU. To prevent this, the OS uses a timer. Before handing control to a user program, the OS sets a timer. If the timer expires, it generates a hardware interrupt, allowing the OS to regain control, switch to kernel mode, and decide whether to continue the program or give the CPU to another task. In summary, the OS is an interrupt-driven system that uses multiprogramming for efficiency, multitasking for user interaction, dual-mode operation for protection, and timers to maintain control over the CPU. Thank you for your time. See you in the next session. Bye!